All right, so let's continue our further applications of right triangles. And we're going to focus on our more word problems that have to do with bearing. And what exactly is bearing? So bearing is kind of how we describe navigation. So it's very important. It's an important concept in navigation. So with navigation, right? With navigation. And what we want to do is we want to express the bearing, right, clockwise from due north. And if we do that, that means that this will be a single number. Okay, so what do I mean by that? So here is my due north. Okay, and then so here I'm gonna put a little north symbol there, and so that means that my bearing is coming out. So again, this will be my initial side, still my terminal side. So a little bit different than what we're used to, and we will always go clockwise around. So we'll kind of talk about this. So if I say draw the bearing of 50 degrees, right? So again, let's think about what this means. Again, here's my north. So think of this as 0 degrees, which means that this would be your 90 degrees. So the bearing of 50 degrees would probably be somewhere right about there. And then again, we would draw the arrow pointing that direction. Let's do another one. Let's say we had, I don't know, 123 degrees. So again, here's my due north. So again, this is 0. This would be 90. This would be 180. So it'd probably be somewhere right about here, I would think, somewhere between 90 and 180. And so again, we would talk about bearing. Okay, so this would be when it's a single number, right? So we can talk about not necessarily a single number. We can talk about it as two directions. So you might have heard the expression like north by northwest, or south by southeast. Okay, so when I think of my chart, right, so here is my x-axis and y-axis, but again, I'm going to call this my north, south, east, and west. Okay, so if I have something along the lines in here, notice that I'm between my north and my east. Okay, so again, I'm between 0 and 90. The north or south always comes first. So N or S always comes first. So if I wanted to deal with this, this would be north by some number. So it'd be some number, and then east. So for instance, it might be north by 14 degrees east. So again, I'm in between north and east. And really that 14 degrees is right here. So this is your 14 degrees. Okay. If I was in between here, again, this would be north by some number west. And whatever number that is, that number would be right here. Okay. If I drop down into this quadrant, again, I'd be starting at south, so I'd be going in that direction. So I would say south by some number west. And then if I was over here, this would be my south by some number east. So again, I'd be going in that direction. So again, we always use, north or south always comes first. It's also important to, we want to use acute angle to show our direction, especially with this type of diagram. Okay, so we'll be doing a couple of these problems to kind of see kind of what is happening. All right, so let's jump into our first word problem where we have to also draw a lovely picture. So here's our first one. All right, so it says radar stations A and B are on an east-west line 3.7 kilometers apart. Station A detects a plane at point C on a bearing of 61 degrees, while station B detects the plane on a bearing of 331. So the 331 and 61, it's going to be very similar to this kind of bearing, single digits. Okay, we want to find the distance from A to C. All right, so let's start with our first part. So east-west line. So an east-west line looks something like this. So, so station A and station B. So before I label which one is A and which one is B, what I do know is that they are 3.7 kilometers apart, so I do know that information. So they have a station C is kind of in the middle of, it should be in the middle of things, because again, we're trying to create right triangles. So if we think about 61, so if I just kind of drew 61 degrees, so again, this would be north. This, if we think about it, is 90 degrees, so it'd be somewhere right about there. So maybe that's 61. 331, right? So again, here's your north. So again, this would be 90 degrees, which means that this is, right, 180 degrees, which means that this is 270. So then 331 is somewhere right about here. Right, so it would be all the way around here. So for 331. So it seems that, so again, this is A, and then this is B. If I kind of move, if I put A over here and B over here, that seems to make a little bit more sense. So I'm going to make this A, and I'm going to make this B. So what I'm going to do is I'm going to draw north symbols right here, and north symbols right there. So point C is somewhere in the middle. So I'm going to call this point C. Okay, so based on this information, let's just pretend that this right here, this bearing, is your 61. Okay, and then this bearing right here, all the way from here to here, bam, bam, will be your 331. So that's what we know so far. So now I want to know what is the distance between A and C. So this is what I'm trying to figure out. I'm trying to figure out what that guy is right there, X. So when I am creating this line, so A and B are on the same line, right? And they are perpendicular, which means, right, that this line and this line are going to create a 90-degree angle. So the first thing I want to do is I want to find this little guy right here. So I'm just going to say 90 degrees minus 61. Right, carry that over. So I'm going to get that as 29 degrees. So this will be 29 degrees. So what I'm trying to do is trying to figure out if this is a 90-degree angle. And it will be. So what do I know by this? Again, north, east, west line. Okay, because again, this is the most important piece of information right here, east-west line. And I'm going to try to figure out this angle. So I know that this is 0 degrees, 90, this would be 180, so this must be 270. So I'm just going to go 331 minus 270. So I'm going to borrow, right? And this will be, so this will be 1, and then, what, 6. So then this will be 61 degrees. And then I'm just going to add those together up and see kind of what I have remaining. So carry the 1, 8, 90. So these two add up to 90, which means by default, this has to be a right angle. Okay? So again, we're just kind of putting all the pieces together. Okay, so now I know the actual hypotenuse, and now I just need to know what this length is. So again, I can either use my 29 degrees or I can use the 61 degrees. Let's go ahead and let's use the 29 degrees. So if I use, too far, sorry. If I use my 29 degrees, so I'm going to take this x, so this will be cosine. So the cosine of 29 degrees is equal to adjacent over your hypotenuse, 3.7, and then this will be whatever 3.7 times the cosine of 29. So this will be equal to x, or aka my AC. So let's go ahead and pull this up. So turn this on. So 3.7 cosine of 29. And so it's going to be 3.236. So we'll just say 3.236 for the distance. And again, this is in kilometers, so let's go ahead and add those kilometers up. And that's it. Okay, so we're kind of putting all the pieces together to try to figure out kind of what we're doing. All right. Let's go ahead and try an easier, let's try an easier problem. So let's jump to this one. Okay, so let's solve for h. So again, I have a little right triangle here, and then this large triangle right here in order to find this one. So in order to actually find h, I actually need to figure out what this guy is right here. Okay, so I'm going to use my larger triangle, and we actually are going to have to create a couple of these. Okay, so first thing I'm going to do is I'm going to say that the tangent of 222.2 is equal to opposite, so h, all over 50 plus x. All right, and I can create my other triangle, so this will become the tangent of 36.7 is equal to h over x. Well, since they both have h's, I bet I could use some systems of equations to kind of help solve for this. So I'm going to go ahead, I'm going to say that this is 50 plus x, parentheses, tangent of 22.2 is equal to h, and this will be x tangent of 36.7 equal to h. All right, so they're both equal to h, so let's go ahead and distribute. So this will be 50 tan of 22.2 plus x tan of 22.2, and I'm going to set that equal to x tan of 36.7. I'm going to collect my x's over to one side, so 50 tangent 22.2 is equal to x tangent 36.7 minus x tan 22.2. What do they both have in common? They both have x's in common. So let's factor those out. And I'm going to go ahead and divide everything. So, too far again. So I'm going to have, for my final answer, I'll have tan 22.2, multiply that by 50. I'm going to divide it by whatever tangent of 36.7 minus the tangent of 22.2 is. And that will give me my x. And once I know my x, I can plug it in for my h. So, whew, a lot of work. Let's go ahead and do this. So 50 tan 22.2, close parentheses, divide it, open parentheses, tangent 36.7, close, minus tan 22.2, close, close, press enter. 60.496. So let's just round it to 60.5 approximately. And then, again, try to figure out which one is easier. Seems like this equation is going to be a little bit easier to solve for. So I'm going to go ahead and use that guy right there, bring it down. So, really I'm going to say this is equal to x. So 60.5 times the tangent of 36.7. That is equal to h. Go ahead and bring this back up one more time. So I'm just going to say times tangent 36.7. And we are going to get a grand total of 45.09. So again, h is equal to 45.09, or we can round it to 45.1 roughly. It didn't give me any, I didn't write any of markings, so inches or anything squared and stuff like that. And that's how we would solve that. We're going to do one more word problem in the next video.